Hey everyone, this is Fix Reef, and today we have a Radion XR30 that does not turn on. Uh, if we were to attempt to plug it into power to test what's going on, we will see that not only the lights don't come on, there is no fan spinning, but also the lights on the front here, the lights that are under these buttons, don't turn on at all, and they are not blinking whatsoever. This indicates to me that this light is going to have a problem somewhere in its power circuit as opposed to an issue with the LEDs themselves, or LED pucks, or the modules, or anything related to the channels that control different colors of LEDs. So let's take it apart and see what's going on there. Let's get started. Okay, so first things first, we noticed that well, the RF module is not seated properly, it's off by one. So someone took this light apart before trying to diagnose or fix the problem. Typically, when the RF module is not seated well, it's not a huge deal. The light is not going to work, it's not going to turn on, but it's not going to necessarily have the symptoms that we're seeing here. So it's not this module, not the RF module that's causing trouble. So first what we're going to do is we're going to power it on. Well, first, actually, what we are going to do is, what I like to do is disconnect the power. This is the actual power from the power supply, and instead I'm going to have my lab power supply provide some power to it. That way, I have a better control of how much current I'm going to feed into the light. So if there is a short, if there is a big problem of some sort, I have a better control of preventing more significant damage here. So I'm just going to plug in my small adapter, provide some power to it, and we're going to do some testing. So first off, we are gonna make sure that we receive 35, 36 volts on the power pins over here. So about 36 volts. Now we should be able to get the same here at the fuse and on the other side of the fuse as well. So the fuse is good, everything is good. So the problem is somewhere else on the board. So let's find out where it is. Disconnect the power. We no longer need it, as we're going to be taking this whole thing apart. Let's see. So first, let's remove LED pucks, LED modules from this light. What I do see when I open these lights up typically is that somebody's been here before, right? I see some residue of thermal paste here and here. Obviously, the RF module wasn't seated properly, so somebody's been here before. I'm not sure if they were upgrading the lights, if they were trying to diagnose the problem, whatever it is, they caused that light to fail. Or something caused that light to fail, and then they try to fix it. Whatever it is, doesn't matter. What we are going to do today is we are going to attempt to find where the cause of the problem is and try to fix it. One of the challenges of working on the reef gear and reef equipment like this is that, unlike working on, say, laptops or phones, trying to fix them, there are no schematics available whatsoever. So we are going to have to deal with the fact that we do not know what exactly is going on with these lights. We'll have to guess, and we'll have to use troubleshooting techniques to find out where the problem is, where it lies, and what we need to do to fix it. A fair amount of thermal paste on these guys. So this causes the fact that we don't have the schematics causes some problems, some grief, but it's not the end of the world. As I've been fixing these things for a while, I kind of already know what. This one's kind of broken as well, but that's not a problem. We can fix that as well. Okay, so we're disconnecting the buttons on the front. We just disconnected the power or the LED modules. We're going to disconnect the fan, and it looks like all we need to do now is remove the board for inspection. All right, so far so good, and it's off. All right, so we won't need the actual light anymore, so that's going to go away for now. Let's focus on the board. So this was the side of the board that we saw previously. This side of the board looks to me fairly clean. Looks fairly clean. I'm not seeing much of it. There's some discoloration here. That's probably the thermal paste as they were trying to replace the LED module. So not a big problem. Here is where we have all the logic for all 6 channels, plus the USB connection, the main CPU, and the power here. So what I see right off the bat is, I'm not sure how well you can see this, but there's quite a bit of discoloration over on this side. This is where the main power comes in. And we see discoloration here, we see things here. There's something going on this side. Otherwise, the rest of this board looks fairly decent. So what we're going to do now is we're going to inspect this area under the microscope and see what we can find. So what do we have? Ooh, that looks bad. All right, so hopefully you can see this. There is some type of discoloration. Somebody's been here before too. I see some scratches, but there is some type of discoloration going on here, some oxidation. Clearly there was some salt here at some point. I see some salt creep here and there that ate away at the copper, ate away some of the solder around this MOSFET. And that's bad, but that's not horrible. There's a little bit of oxidation over on this side. These ones are fairly good, but this is corroded. So there was some kind of corrosion on this. We may have to replace this MOSFET. But look at this, right in this area. Right in this area. There's supposed to be two resistors. I think resistor 109 and resistor 110. Resistor 110 is missing. The pad under resistor 110 is missing. It's supposed to lead into this via. That's also gone. And on this side, this resistor is there, but the pad is clean, so there is no solder connecting this resistor to the board. So that resistor might still be okay, but it's not soldered in anymore. So we have a problem. What happens here is that the power comes in. This is, again, see how thick these traces are? That's the main power coming in, 36 volts, like 4 amp or whatever it is, 3.5 amps. This is the opto isolator over here. And so there's this main power moving around here, and it's being controlled by this transistor and this transistor as well. And right now, this leg of the transistor, this pin, is not talking to anything else on this board. So we've got a problem over on this end, and we need to restore and solve this before we move on to the next, if there is any other problems. So, but in the meantime, let's finish the inspection a little bit closer and see if there's anything else that is going to be a problem. I'm not seeing everything. It mostly looks clean. I'm looking for holes, burned components, missing components, major discoloration, and potentially other problems. But everything looks fairly clean. That's the main CPU. Also looks pretty good. And this is the USB port, and that looks good. No, everything looks fairly clean. Over on this side, I'm not seeing any more issues. So I bet that the two resistors that are in place there are likely, that are missing rather, are likely causing us most of the problem. And I'm not sure if I'm going to be able to trust this MOSFET as well. So we may have to replace it too. Okay, so let's see what we can do. So this is actually a fairly common circuit here. This circuit, this is a Gen 3 Radion. This circuit existed since Gen 1 probably. I've seen this before, but it's in a different location and different configuration. But this exists elsewhere. So we'll need to find out what resistor we had here, what kind of resistor we had here, and also solder this resistor back in place, assuming that it's functional, and restore this pad. This via is a concern as well. So this via, let's see. This via leads us to this trace over here. That's the trace, that's the other end of this via that takes us down to a few more. I can trace them. It takes us to probably the main power here as well. Let me take a look at my donor board from a previous generation of Radion. That's a completely disaster of a board. This board is supposed to have very similar components. So here's the opto isolator, same type sitting here. Here it's connected to the transistor. Now this transistor over here is connected to this, so we can kind of compare and see how similar they are. So we have this board over on this end. Let me set them side by side. They're kind of different, kind of similar but different. So here is this opto isolator and the two transistors that it's connected to. Here is our end. Let me see how well you can see this. But here's the old one. The old one, similar to this, is connected from this pin over here to this transistor and this resistor rather, and this capacitor over here. And that's this resistor and this capacitor. So those are pretty good. We don't have to worry about them. But it's also, on the other hand, connected to this missing resistor and the resistor that's not connected to anything right now. So this is happening over this via over here, over on the other side of the board. So let's see what that looks like. So this is our via, and it goes here. So bring this back here. Yeah. So resistor 124 is the missing resistor, and resistor 122 is the resistor that's not connected to anything, right? Anything whatsoever. So what I'm going to do is I'm going to measure these resistors to see if I have spares, and if I don't have spares, I'm just going to use these resistors to put in place to see if everything is going to work. All right, so what we're going to do now is attempt to remove the resistor 124, because resistor 124 is the one that's going to be that's the one that's missing, and see if we can measure resistance on it. So we're going to add a little bit of flux, and we are going to attempt to grab that resistor and move it off the board. I usually use the hot air station for this, but these components are so tiny that at that point you can potentially blow it off the board, and that is something that I cannot do right now because I don't want to lose the component. All right, so this resistor is now off the board, and let's measure the resistance on it. About 41.2 kilo ohms. All right, 41.2 kilo ohms. All right, so what we're going to do is I'm going to put this resistor aside for now. All right, so now we are going to try to measure resistance on the one that we currently have on the board, assuming that it's likely not connected to anything because the pins are all done. And this is 47. It's reading as 47.5 kilo ohms. So 41.2 and 47.5. Okay. So this resistor we likely can save. I'm not gonna mess with this resistor, but the other one we'll have to replace. All right. So let's replace. First off, we need to clean up the pads. All right. A little bit of flux. See how tiny these components are. It'll be impossible to work with them without a microscope. These resistors are 402 size resistors, which is some of the tiniest components that we currently have to work with. Okay. Okay. Looks like we have and while we are at it, why don't we try to save this guy as well? All right, so we're going to add some nice leaded solder to the resistor that is currently missing all of it, so that resistor stays secure in place while we are working on the remaining pads. Okay, looks like we need some more flux. There you go. Okay, that looks fairly good. All right, so we'll need to focus on fixing the pad. Before we do so, we'll need to clean up the area from flux, and then figure out what our strategy is going to be on repairing the missing pad. And more importantly, the bigger problem of this whole thing is that the via is also corroded quite a bit. So I'm just cleaning this area with a little bit of alcohol. Actually, all this area over here too. All right, so now we just need to figure out how to fix the via. This via is completely missing to the point that there is no way for me to solder to it, but I have to do something because it needs to connect. It needs to connect outside. So to solve this, this is our via. To solve this, we will have to likely run a jumper wire from the resistor to the other side over, from here over, around, and there. Okay, we can do that. So first, we're gonna add some solder to the remaining pad, so that's important. I'm gonna add a little bit more here as well. Yeah, I don't think I can trust this resistor. I think this resistor is corroded and needs to be replaced as well. So we might as well do that. I think that it corroded to the point where it's not gonna work. All right. And that's okay. We'll clean it all nicely. We'll replace all of these bits. I don't have time to waste trying to restore a resistor that costs 1 cent. Okay. Let's clean up the area again. Very nice. Okay. Cool. Okay, so we have all the pads tinned. So now all we have to do is just so what we're going to do first is we're going to take the resistor that we didn't take from the donor board yet, the one remaining resistor, and place it on the board on the new board. Okay. Again, these resistors are the components are so tiny that it's super delicate and dangerous, because if it flies, I will never ever be able to find it. So we want to make sure that they are in place as soon as possible and they stay there. Okay. Doesn't look pretty right now, but we're going to clean this all up once it's all in one, once everything is in place. So why don't we put the other resistor in place as well, and then restore the pads. We can attach that one resistor to the board as it is over just one pad. All right, now let's clean this up, because this is going to help us eventually get all of the wiring done correctly. Let's clean this up a little bit. So what we do need to do is, first we need to, as we run the wire, we're going to need to run it over from one end of this resistor to the other end of the other resistor, and then across the board over onto the other side. But first we need to get this this via cleaned up so that we can solder to it. Clean it and prepare it for. Okay, very good. Okay, add a little bit of flux and tin it. Again, this is so that when we do run a wire, it connects quickly and no issues. Okay, that's good enough. All right, now we need to have a wire running from one end of this to the other. All right. Oh, we also need to tin the other end of the resistor so that there is plenty of nice solder there. Okay. All right, now the wire. Okay, so we're gonna add some flux. to help the solder flow in the right direction. We have the iron that is quite warm. So all we need to do now is attach the wire to both ends of this resistors, 1 and 2. Okay, we got one end. Now we can hold it in place and do the other end. All right. Now we have to run the wire around the board and onto the other side and connect it to this trace. So we're going to need a little bit more flux. And we're going to attach this wire. We're going to bend it 90 degrees and attach it so that it has the best possible contact with the trace that is going on. And then we're going to cut the rest of this wire off. Okay. All right, so let's secure it in place. You can see that as the wire heats up, it loses the protective coating, and the solder with flux gets attached to it right away. It's a nice copper wire, and that's also fairly thick. It's super tiny if you look at it without the microscope, but then under the this magnification, it looks super thick. But it's just enough to do what we need to do to conduct the signal. This is not a power rail, it's just a signal rail. Beautiful, beautiful. Okay, so all we need to do now is cut off the wire. Done. Clean everything up, but very gently, because we don't want, this wire is still not properly secured. So when we clean, we just want to make sure that that we're not breaking it off. Again, this side, and a really nice cleaning on this side. This is all done with 99% isopropyl alcohol to help with the cleaning, but at the same time not leave any residue. Okay. A little bit with the brush just to get. Okay, so and that's what we have. Hopefully you can see the final product. Not quite final product, but it's getting there. So next we need to add some masking compound to insulate, in part to insulate the wire, although the wire is kind of already insulated well, but also in part so that we could hold the wire in place, because we don't want it to move. So to do so, we're going to apply this green PCB masking liquid. It's a special liquid that hardens when you apply UV light to it, and it becomes as hard as what covers the PCB. Right now, see, this wire is moving with my pick, which is not the best thing. So we're going to cover it in this green liquid. Doesn't have to be a whole lot, just a little bit. Tiny little bit will go a very long way. I have a 10 ml tube of this, and it's going to last me forever. And now we're just going to apply some UV light to it and let it sit and let it harden a little bit. All right, so the mask is now hardened. You can see that I can scrape it off a little bit with the pick. Everything looks good. Same as on the other side. Everything looks really good here. Everything looks really good here. So this is mostly complete. So now all we have to do is, all right, so the next thing we will have to do now is just connect the power supply over here and see if it draws any, if there is any difference, if it draws any more current than it did before. So I'm going to connect my old bench power supply to this and power it up and see if any smoke comes from it. Okay, we have about 0.03 amp draw, and I heard a click. I'm not sure if you could hear a click, but I heard a click. This means that the board is now powering. It's obviously no pucks are connected to it, no LED modules are connected to it, but it's powering once again. See if you can hear a click. There's a click. Click means that we have power to the board now. All right, next thing we're gonna do is we're gonna assemble it into the light and see if this is working. So we're gonna get back our fixture case and let's reassemble. Okay, this looks fairly solid. I'm being very, very careful with this this connector. It's already not very stable. We don't want to make it any worse. Okay, we can connect. We're going to connect just for testing. We're going to connect these LED modules without replacing the thermal paste. I'm going to actually fix the thermal paste and do more work on those later. But for now, for testing purposes, this is going to be sufficient. Okay. I'm going to connect the fan. And we're still going to connect my power supply because I don't want to smoke anything with the more powerful power supply that came with the light. I also don't want to connect the RF module right now because it's not going to be necessary, I don't think, to power everything just for testing purposes. So let's see. Now let's see if it's working. Okay, it's on and it's off. The fan is spinning. The light goes on and it's off. On and it's off. This might actually not be the light problem because I have limits on the current that I have on my workbench power supply. We're going to increase the current on this light, on the power supply, so that it provides enough current for it to start running. So let's see what happens now. And it's on, and it's working. All right, we're not going to run it for too long because we don't want it. We don't want it to fry because I still need to replace the thermal paste and touch the modules properly. But I think we just fix ourselves an XR30 Gen 3 light. Hopefully you enjoyed this video. Please like and subscribe to the channel if you would like to see more content like this. It definitely will help the channel. And I will see you in the next video.